Today, we're talking to John from the Fuels Institute. I remember you telling me at the NAC show, actually, when you're thinking about or already working on this new report that you've recently launched. And, we're all quite excited about it because there's been a lot of discussions around life cycle of electric vehicles versus IC internal combustion engines. So the report's finally out. It's called Life Cycle Analysis Comparison. And, we're here to discuss some of the highlights of this report, which I understand it's been quite hard to get around. Maybe one of my first questions to you, John, I know you've had some people working with you on this, is how challenging was it to approach this task of looking at the whole life cycle analysis?
Well, when you start off with the objective of providing just objective analysis, it's not that difficult because you're not trying to prove a point. You're trying to just say, hey, let's take a look and see where things are. So we contracted Ricardo Consulting, which is a global consulting firm. They've done a lot of research for us. What we asked them to do is take a look first at the literature on life cycle assessments on electric vehicles, combustion engine vehicles, hybrids, understand what is already known, then use the prevailing documentation and research out there to develop our assumptions and our inputs, run them through Argonne's GREET model, which is the gold standard in the United States for doing life cycle analysis. Very transparent, very open, very repeatable. So we didn't want a black box. We want to make sure that everything we did could be validated. We ran the GREET model, compared the results to see if we had calibrated it consistent with what the leading LCA reports had done. So once we had that, now we can start doing some detailed analysis in terms of different levels of life cycle and then start creating scenarios to find out what happens when you are operating in a heavier carbon electricity grid, when you're driving aggressively, when you're driving in cold weather compared to warm weather. But we had to set that baseline. So, it really comes down to, if you're focused on being transparent, open, and honest about it, it's not that challenging because, again, we're not trying to prove one point or another. We're just trying to provide insight.
Yeah, which I think it was great about your whole approach by the Institute and by the consulting firm to this whole task. So I've got a couple of slides here. I firstly want to encourage everyone to go to the Fuels Institute and download and read the full report. There's a couple of videos on your own YouTube channel where you discuss it with the authors, as well as a summary that you have yourself. Some of the slides that we'll see actually come from your own video. So let's look at, for example, this first slide. And so John, we probably had an idea of what you were going to get to through the report, but what have been some of the major findings that you've seen, and what conclusions do you take from it?
Well, I think most people assume that electric vehicles would have a lower life cycle carbon emissions profile than a comparable combustion engine. And it came out true. We looked at the average US electricity mix, and we looked at a 200,000 mile expected life. And that's what the design elements are. So we're not driving vehicles 200,000 miles, but they're being designed to run 200,000 miles. So that's why we ran the model that way. And we expected to see a benefit to electric vehicles on average. The challenge comes into where are you operating the vehicle and when are you operating it? So we can get into that in a few minutes, but I think probably show that slide on different geographic regions. But I think what's really important here is we broke it down by life cycle, from material sourcing to manufacture, well to tank, tank to wheel, disposal, recycling. Take a look at where the emissions are being generated. You've got almost 3/4 of a combustion engine vehicle's carbon emissions happen during the operating cycle. So when we're burning liquid fuels to move the vehicle down the road, that's when 3/4 of emissions are. So if we want to address emissions from combustion engines, and we cannot wait for electrification or any new technology. There's too many combustion engine vehicles on the road, too many going to be sold over the next 30, 40 years. We have to address emissions there. The only place to really focus is on that fuel side. So how do you reduce the carbon intensity of fuel? I think that column there for ICE really demonstrates that. When we look at the battery electric vehicle, 3/4 almost of emissions from that come from electricity generation. And that is a huge element. So how do you improve the carbon intensity of the grid that's supplying the fuel to power the electric vehicle? So the two different areas, we can address the emissions in both. We got to address them in different areas. The other thing that I found interesting is the manufacture of a BEV, before you put any miles on it, it's about 2 times more carbon intense than manufacturing a combustion engine vehicle. And that's largely because of the battery elements. How do we reduce carbon emissions in the manufacture and design of an electric vehicle to provide a greater advantage off the line rather than having to wait 20, 30,000 miles before you offset those emissions? So again, nothing really surprising here other than helping us really focus our attention on where can we have the greatest impact on emissions for the different powertrains. And let's focus on that rather than focusing on this, let's replace everything with electrification. No, let's focus on reducing carbon because that's what the objective should be. It should not be pushing electric vehicles. Electric vehicles are a tool, they're a resource to the greater purpose of reducing carbon. And I think that's what this slide really shows, is that we have some opportunities here to narrow the gaps between these technologies on carbon emissions if we focus on the areas that have the greatest impact on their life cycle emissions profile.
Yeah, and as you say, it's about what we can do today, what we can do day after tomorrow, and what we can do in years down the line. So I know there's a couple of slides that will come down where, it's really interesting also to look at what we can do with that, those 3/4 of emissions that come from the actual use of fuel in ICEs.
Right.
In the next slide, I think, if I can get to it. Here's some of those external factors that you were discussing, John. So maybe you can guide us through what we see here.
So this chart is not in the report. This is a John chart. I took the data from what Ricardo wrote and I said, I want to understand what impact these external variables have. So again, I mentioned we calibrated the GREET model. We baselined that, compared it to prevailing literature on an average basis. Then we said, okay, what happens if we change certain parameters? What if instead of 200,000 miles, a vehicle only runs 100,000 miles? What if they're operating in a low, high, or extremely high carbon grid? Now, what does that mean? An extremely high carbon grid is going to be a grid that's powered almost exclusively by burning coal. Okay, so put it in context for that respect. There's a lot of people saying, well, battery electric vehicles are terrible in cold weather. We want to understand, how do they fare against combustion engines? And so you look here, and the percent over on the left axis is, if it's a positive percent, that's your increasing carbon emissions over the lifetime. So clearly, if you drive it less, you're going to reduce your carbon. If you drive an electric vehicle in a low carbon grid, the benefits are significant. I think instead of a 41% carbon benefit compared to combustion engine, it's like 71%. So you're benefiting from hydro, renewable electricity sources, because as I mentioned, almost 3/4 of your emissions come from electricity generation. It stands to reason that if you have a lower carbon grid, you're enhancing the benefit of the electric vehicle. But when you look at the high carbon, extremely high carbon grid, you see significant increase in emissions. And actually, in the extremely high carbon grid, the battery electric vehicle emits 19% more carbon than a combustion engine vehicle. The other thing I think is interesting here is on the purple and gray, and that's the 10 degrees Celsius colder, 20 degrees Celsius colder. I really think this red herring that electric vehicles are terrible in cold weather is really just that. It's trying to disparage the technology with data that's not necessarily borne out by the model. You do see a 28% drop in range and an increase in carbon emissions for the battery electric vehicle in colder weather. But you see an increase in carbon emissions in colder weather for the internal combustion engine. Just like you see a reduction in miles per gallon when you're running your heater all the time in your combustion engine, just like you want on an electric vehicle. Same thing true for aggressive driving. If you are a type of driver who stomps on the gas every time the light turns green, slams on the brakes every time it turns red, your miles per gallon goes down. If you do it in an electric vehicle, your range goes down. And consequently, your carbon emissions go up because you're recharging more cycles to go the same miles. So it's just interesting that every single category, the vehicles are all affected by external variables to a degree. There is a greater degree of variability for the electric vehicles, but is predominantly focused on the electricity grid. So it's important to understand that you can throw technology in the market, but you have to understand beyond the technology capabilities, what's happening around the technology that's going to influence its impact on the environment. The vehicles being run in a coal-dominated electricity grid, the electric vehicle is not the right choice. If it's being operated in a very cold weather, is it really a negative compared to combustion engine? Not as much as people would think. So But as we bring these vehicles to market, we have to teach consumers how to drive. We may all know how to drive, but if we're focused on emissions reduction, teaching them how to drive environmentally sensitively, to take advantage of the capabilities of their vehicles, is another layer of consumer education we need to really be thinking about.
Yeah, it's funny because so a lot of these events that me and you go to, and I think you've been to quite a few more than myself, the cold weather argument is definitely one that you used to hear very often, right, against the electric vehicles.
Right.
What would you do with the battery electric vehicle in Alaska? That would never happen there. So it's very interesting to see that actually the impact is not as high as some of us.
It's interesting, Oscar. I mean, they say that, but what's the #1 market for electric vehicles in the world? Norway. Not a very warm climate. So it's kind of interesting that we throw that as an attack against the viability of electric vehicles. It's not necessarily borne out in the data that we did through the model, but if it's so bad, now, obviously you're not driving as many miles in Norway as you do in the United States, but it does pretty well in that climate. And so, I think we can argue against any technology with any type of attack, but you got to really look at what is the fundamental experience and what does the actual data say before we start taking those attacks as the truth and vindication of somebody's position.
Yeah, absolutely. So I think here, this is a very important topic that you were discussing, because the numbers that you showed in the summary, that 41% of lower emissions is kind of based on the US national grid, if I'm correct, right? Which we could say has like 46% of clean energies for the production of electricity around that. So in Europe, I think we're about 46%. We're like 10% more of clean energies. If we looked at China and some areas of China, obviously where they still use a lot of coal for the production of electricity. So is this an argument, would you would say, as our countries are becoming greener in the production of electricity, the argument for battery powered vehicles is going to be more and more overwhelming? Do you see that happening, or
yeah, I mean, as I say, 3/4 of your emissions come from the electricity grid. So it stands to reason that even in a low carbon electricity generation market, your advantage on carbon life cycle emissions is so much stronger for an electric vehicle than it is in a coal powered community. What this chart shows is that a one size fits all solution to decarbonization doesn't work. We have to think about deployment strategies. Where does it make the most sense to deploy a battery electric vehicle? It makes more sense to deploy it in a green community. It makes more sense to focus that in societies where the generation of electricity is renewable, where it is lowest carbon. If you're going into a market where the grid is extremely high carbon intense, maybe we don't bring battery electric vehicles. Maybe you bring in hybrids and take a look at the difference there. It's a significant savings at 27% carbon reduction compared to a combustion engine vehicle for hybrid, but about a 43% savings compared to the electric vehicle. So understanding the nuances of market dynamics, whether it be country level or regional level, and deploying the technologies that make the most sense to achieve the objective, which again is reduce carbon. The objective is not promote electric vehicles, it's reduce carbon. We need to be smart about it. The challenge is when you start getting into these complexities, you'll lose a lot of your audience. And if I'm a politician on a stump speech, it's very easy to say, we got to push electric vehicles everywhere. Everybody goes, oh, I understand that. So going, we need to send electric vehicles to California and the Pacific Northwest, but we need to send hybrid vehicles into the Midwest and combustion engine, high efficient vehicles here. It gets really muddy quickly. The problem is, if we're going to be serious about this, we need to get into the mud. We have to get into the muck and really figure out what are the specific strategies that make the most sense, and then deploy them that way. Because in that respect, you can have the greatest effect on emissions, but you can also have the greatest effect on the economic impact on consumers. And I've said since day one, we launched the Fuels Institute 9 years ago, is if a strategy is unaffordable for the consumer, it will fail. And so we have to think about that as we go forward. And I think this report we put out there was designed to help prompt that thinking and prompt those discussions so we can be much more strategic about how we go to market.
Yeah. So as you say, it's about creating an effective strategy that can be applied in a flexible way, depending on the region. Even in countries as big as the US, you could have different strategies for different states. So do you feel like hybrids is kind of like the forgotten, the missing piece of this puzzle, that actually it could be a very good way of bridging that gap between those different economies?
I think hybrids have a huge role, and we did not model plug-in hybrids. So there's a different dynamic there because you're benefiting from the grid or you're sacrificing from the grid. But hybrids, look, across the board, they're lower emissions than a combustion engine vehicle. They're lower than electric vehicle in the high and extremely high carbon markets. So they're more universal in terms of their benefits to the environment. They also negate the need for infrastructure. So you can bring a much more environmentally sensitive vehicle to market at a lower cost of acquisition than a battery electric vehicle, a little higher than a combustion engine vehicle, but you can bring it to market and not have to spend billions upon billions of dollars on charging infrastructure. And so now the challenge is it doesn't get you as far down the path towards carbon reductions as is deemed necessary. But it is a huge interim step, especially in markets where electric vehicles don't make sense. Either the communities are set up in such a way that they're driving too far, recharging times aren't sufficient, it's just not feasible, or the grid is not supportive of an EV strategy. I mean, the hybrid brings great value. Now, you take a look at light-duty vehicle sales in the United States in 2021, hybrids at 6% of all vehicles sold. It's a reflection of OEM strategies during the last CAFE program, 5 years out, planning to bring these hybrids to market to satisfy CAFE. The momentum has shifted to electric vehicles because electric vehicles are deemed to be cleaner over long term and in the big picture, but they carry with them a lot more challenge than hybrid. Hybrid doesn't require the consumer to change behavior at all. And maybe, you bring more hybrids to market now, and as the grid gets cleaner, and battery electric vehicles seem to be more universally beneficial to the environment, they come down in price, they increase their range, recharging time accelerates. Maybe you bring electric vehicles in at a later time more aggressively. That's a discussion we need to be having. Unfortunately, I don't see it happening because, again, it gets into the muck. It gets into the complexity, and complexity is the enemy of expediency when you're trying to push policies and programs. So I'm hopeful that those who are responsible for the decarbonization strategies at the government levels look at stuff like this and look at the details and realize that you may have your press release, you may have your stump speech and your soundbite, but underneath it, we need to be much more strategic and encourage the industries to address our carbon emissions challenges in a way that makes the most sense for the region they're servicing and for the consumers in those markets.
Yeah, and when we talk about smart solutions and what we could do today to reduce our carbon emissions, I feel like this next slide is really important because it's not maybe the sexiest topic for politicians or for the lobbies, but in terms of this one about fuel blends and what we can do today to reduce emissions, as you say, in ICEs. There's almost 3/4 of the emissions comes from the actual impact of the fuel on the vehicle, and this where I feel we could do a lot with less for the near future. So what are some of the basic findings that you see here, John?
So we all know that biofuels have a much lower carbon intensity than petroleum-based. The challenge we run into is when you are limiting the volume contribution of the biofuel to the fuel split. So we're charting here E10, E15, E15 cellulosic, diesel, B20, and renewable diesel 100. We are limited in terms of how much ethanol we can use in gasoline, either from regulation or equipment vehicle compatibility, feedstock constraints. We've got limitations. We have more flexibility in biodiesel. You can get up 20% compared to 50% ethanol. Renewable diesel, it's considered a drop-in, so you can be 100% renewable diesel. You see the difference in carbon benefit when you increase the volume of biofuels. And so the question comes into, all right, are the regulatory structures, are the compatibility standards appropriate, and do they have the potential to evolve to allow us to take advantage of the carbon advances associated with biofuels? And I've seen studies, and I know that we're starting to have even greater impact on the carbon intensity of biofuels to make them even more advantageous. So how can we take advantage of that? It may require a reconfiguration of the regulations. It may require some changes in terms of vehicle compatibility and equipment compatibility standards. Don't know the solution, but I think what we have, we're trying to address 75% of the emissions from the combustion engine vehicle is from the fuel. We have to do a better job of taking advantage of the lower carbon fuel options that exist. I know there's tests on renewable gasoline, we got renewable diesel. How do we capitalize on that? And it's going to have to be strategic, because we're running into some feedstock competition with sustainable aviation fuels and marine fuels. And so what is the scalability? What is the applicability? And how do we do this? How do we address carbon emissions from combustion engines? In the United States, about 260 million light duty vehicles. Less than 1% are electric. So 99% of all the vehicles on the road today are combustion. We have a new paper coming out in the next month or two that IHS Markit did for us, and they forecast in 2030, there'll be 18 million electric vehicles, 307 million light duty vehicles. So electric vehicles will be less than 6%. So in 8 years, 94% of the vehicles on the road are going to be combustion. And that's going to be about 20% of sales, 25% of sales. So 75% of new sales are going to be combustion. So the combustion engine is not going away anytime soon. And if we're going to sit in our hands and wait for technology and market turn to reduce carbon, how much carbon are we going to emit into the atmosphere during that time period? And we know that a ton of carbon emitted today is going to be there in 100 years. So we have to be serious about addressing the legacy fleet and the new to market combustion engine vehicles and reduce the carbon of the fuel that's powering those vehicles if we're going to have any progress on carbon mitigation. And I think any failure to address that is an absolute abrogation of responsibility, because if our goal is decarbonize, we have to look at the entire suite of resources we have available to us and be much more thoughtful and much more assertive about right-sizing our solutions to the challenge that stand before us. And I'm hopeful that we start getting to that point soon.
Because those cars are going to be on the road for many years to come, and not a lot of people have the money to buy a first-hand car or a battery electric car, which are today on average more expensive. And it's about how do we fuel those cars in a clean way. And in Europe, we've seen a number of cities now that have committed to banning the entry of diesel and gasoline cars for the year 2030, but that's only a couple of cities. Most of the country will still be using ICEs. So, but what I do see about this is I was in Sweden once talking to Preem, an oil company there, where they've done a lot of work around HVO and renewable diesel. And they got great products, 100% renewable diesel, but they're still importing 40% of that HVO. So do you feel like we're going to be in a bit of a battle for those raw materials to produce the renewable fuels, especially as we're seeing now? You've already mentioned the increased attention around sustainable aviation fuels, which seems like governments and the aviation companies are going to push for that now. So do you feel like we might, in this battle around feedstock and raw materials, I don't know if we're going to have enough to create all the renewable fuels that we need?
It's a major problem. And we actually have a task group that's put together a scope of work for research to see what the scalability is, with consideration being paid to the competition for feedstock. Years ago, there was a lot of discussion about energy dedicated crops for feeding into the biofuels market, switchgrass, those type of things, non-food related crops that could be raised and grown on non-traditional arable land. The economics never panned out. But as we start looking at the importance of renewable fuels and for the aviation, marine markets as well, the demand for those feedstocks is going to accelerate dramatically. How do we diversify those feedstocks? We can't grow, and I don't think that growing more corn and more soybeans and all that stuff is going to satisfy all the demands, because it's extremely land intense. How do we do that? How do we improve the yield of those crops? How do we bring in different types of resources? How do we capitalize on woody biomass? How do we capitalize on municipal solid waste? How do we take advantage of the different resources? And we need to be much more creative. There's been a lot of talk about municipal solid waste conversion into renewable gasoline or renewable natural gas. Are we capitalizing on the full scalability of that technology? I see progress there, but I also see arguments that, well, it's not clean enough because you're incinerating it. It's not going to work. Like, we have to open up the door and open up our minds to what is the art of feasible. We can deal with some of the challenges, but let's start with, we have to see an increase in renewable fuel production. How do we do it? Not should we do it, but first, how do we do it? And then when we started identifying the paths to production, then we started evaluating, okay, the costs and the environmental impact. Okay, option A doesn't make sense. Option B makes sense on a cost, but not environment. Option C, environmentally, but not. We have to have that open discussion and not predetermine the outcome of the dialogue. And unfortunately, so much of this is political, and politics get in the way, and they eliminate that open dialogue that's so essential to creativity. But if we bring together our resources and start really being creative about what is feasible, I think we can find some solutions that we may not have recognized before. It just takes some motivation to do so.
Yeah. So I want to check out one last slide before I let you go. Here we go. Which is the expected price of vehicles, because it's obviously, we know that price plays a huge factor in the public, and if they're going to decide to go for a type of car or another. We've seen that in Norway with all the tax exemptions and the support from the government. When price parity has come to it, it seems like the public has preferred the electric vehicle. So kind of like what did you find here, John?
So this is based on a 10-year total cost of ownership. Now, I think it's important that nerds like me, I look at total cost of ownership. I look at these breakdowns. Your customer buying a car doesn't typically do this. They look at what's the prevailing fuel cost, what's my purchase cost. And I've spoken with the Auto Dealers Association. It really comes down to what's my monthly payment. People buy vehicles predominantly on what's my monthly payment. It may be a $60,000 car, but if I can get it for $500 a month, sweet, I'll do it. And that's why we have 8 and 9 year loans out there now. But you got to, I like this because it breaks it down. You look at the capital cost, and that's what the customer has to pay for. Now, right now in the United States, there's a $7,500 tax credit on a qualified electric vehicle. That doesn't change your monthly payment. And if you don't pay taxes, you don't have a tax liability, it doesn't benefit you the next year very much anyway. You may get a tax refund, but you're not going to save on that monthly payment. So that capital cost is critical. And that's why the Biden administration is talking about some sort of program where you put, they call it cash on the hood, reduce the acquisition cost, reduce those monthly payments. When you start looking at fuel costs, that's where battery electric vehicles and hybrids really step up, and you see a dramatic drop in fuel costs. I don't remember what the average fuel price per gallon was in the calculation on the TCO here, but you can see the difference there. Maintenance and repairs. We include a expected battery replacement, the BEV, over the first 10 years. We expect 1 to 2 battery replacements over the life of a vehicle, based upon driving behavior, how many cycles. At the end of the day, the battery electric vehicle and the hybrid are about 8% lower cost to own over 10 years than a combustion engine vehicle. How many customers are going to do that calculation? Maybe 2% of us. You know, they're going to look at what's my price and what's the prevailing cost of fuel in the market, and they're going to make decisions based upon that. That's after they identify what are my needs, what kind of vehicle is available, what's the color, what are the amenities, all that stuff. But there's an opportunity here to promote a strategy on economics and start looking at, okay, how do we get price parity on capital costs? Most people assume battery electric vehicles to be price competitive without tax credits in the next 5 years. Okay, so that takes out that $8,000 hit on acquisition. That changes the dynamics. That improves your total cost of ownership from 8% advanced to maybe 15% improved for battery electric vehicles. So all this stuff comes into it. It's just a question of, what do customers care about? And we have to communicate with customers in terms that they have. Now, I've also gotten into arguments with people who say that, John, once the EV is price competitive or even price advantageous, everybody's going to buy an electric vehicle. My response is, nah, not necessarily. Consumers are notoriously irrational. And so, yes, I say capital cost is critical. It is, but they're also going to look at convenience. And I raised the spectrum of a family of 5 in the Midwest who has 3 or 4 sporting events and shopping and everything they have to do on the weekends. They don't have 15 minutes to stop at a charger. They just don't have the 15 minutes. And so they're going to be questioning, is this, I have 5 minutes to refuel my car. I don't have 15 minutes. So the convenience factor is going to play in. There's so many things that go into consumers' purchase decision. It's not all about economics. Economics are important, but it comes down to so many other things. How am I going to use my vehicle? These new pickup trucks coming on the market are EVs. They have great purported specs at certain price levels, but is the consumer who takes his off-road gear, like his quads and his motorcycles, out to the desert for a weekend, going to trust an electric vehicle for that drive? Maybe not. So I think there's a segment of the population that's never going to buy an electric vehicle because they don't see it fitting their market. And we have to accept that. We have to accept that we need multiple solutions. But the economics are very interesting. But it really comes down to, we got to look at consumer behavior it's general and not shortcut it by saying it's all about the economics. Economics are critically important, but it's not the only thing being considered by the buyer.
Well, there you go. You heard it from one of the best in the sector. I encourage everyone to go on the Fuels Institute website and download and check that report for yourselves, and keep an eye out for everything that they post. It's all very interesting stuff. So thank you, John, and have a great day.
Thanks, Oscar. Great seeing you. Thank you very much. Talk to you guys later.